Hello, it's Duncan. Last week I had a lot of fun using jqwik for property-based testing of our 10-pin bowling simulator. We found a bug, albeit a minor one, in the construction of new games. This week we'll look at checking properties of games that are in play. This starts simply enough, but we soon run into the problem that because there are 2 balls per turn, we can't represent a game as just random pin counts. If we knock down 8 pins with our first ball, we can't knock down 3 with our second. In the end, I have to introduce a data model for testing which is separate from, and quite different to, our production interface. By the end, I'm left wondering whether this is just an artifact for testing, or whether it's actually a better model overall. We finished the last episode with a number of properties about creating games. So the first one is that a game with no players isn't playable, and in order to test that, we pass any non-negative integer into a number of frames and try and build a game. And for any non-negative integer, we should get a completed game. If this expression returns false for any input, then the test will fail. Another property is that if we don't have any frames, then the game isn't playable. So for any list of player names, a frame count of 0 will give a completed game. We also test for any list of player names and any number of frames that are negative. We can't create a game, so that should fail with an illegal argument exception. And then finally, we test for lists of player names and valid frame counts, where valid frame counts here is anything between 1 and 10, that if we create a game with that list and that number of frames, that it is a playable game. And since that episode, I've discovered we can add an annotation to a list parameter to say that we don't want an empty one. So that's tightened things up a bit. And these tests help us to find at least one bug in our game creation code. But we're not here for the game creation code, we're here to actually play a game. So let's see how we can do that with the property-based test. In order to do so, we need to find an input that jqwik can give us that represents the turns of a game. And so I think we should write a property, and the fun is going to be, we'll keep it simple. Let's say if we roll 20 fours, the game is over. Well, whilst that's true, 20 fours isn't very interesting, but 20 small pin counts is. So we can say roll 20 small pin counts ends the game. So what should this give us? Well, we want for all, and I'm going to call this small pin counts that we'll call pinCounts, and that's going to be a list of pin count. And as we saw last time, we need to write a provider whose name is small pin counts. So we've got some here. What we're looking for is something called small pin counts that returns an arbitrary list of pin count. Now looking at the documentation, we can derive this from another provider. So if we have fun small pin count to just return an arbitrary single pin count, then that could be int.any from 0 to 4, and we can map that, creating a pin count from it. So that compiles, and then we can say here that this is small pin count dot list, and we can say of size, and there are 10 frames, but there will be 2 small rolls in each frame, so we need 20 rolls in total. Okay, so far so good. Now we need to apply those pin counts to a game. So in here we can say val initial game is a game. We'll give it 1 player, Fred, and this will be 10 frames. And now we want to apply each of the pin counts from here to our initial game. And the way that we can do that is to say pin counts fold, given our initial game. And that takes a block here. We can ask to fill it in, where the accumulator is the current version of our game. And as we did in the other tests, we can apply the pin count to the game. So we'll say game.roll, but we can't do that because our game doesn't have roll. We need to cast down to a playable game. So we'll say game as playable game. That will allow me to roll with the pin count. And the net result of all this should be the end game. And if we are right, then the end game is a completed game. That's worth a go. Let's try running it. Good. think we can probably inline the initial game, get rid of the default frame count, and then to give us some confidence, let's print the end game to scorecard so that we can see what jqwik is doing for us. Let's run that. And here we are. You can see that there's one game, there's 2, 3, 1, 2, and so on, all the way to a total score of 36. And I guess there will be 1,000 of those random games, which is pretty smart. Let's take that momentum and assert something else about small pinCounts. If I duplicate this, then the scoring of small pinCounts is easy as well. So rolling 20 small pinCounts should score the sum of the pins. So, getting rid of our scorecard, we can assert something else about that end game, which is that the end game dot lines map it frames to scores. Now each frame has a score, so we're interested in the final one last, and this thing will be a score for each of the players, but we've only got one player. Now, what is our expected score for that player? Well, we take our pinCounts and we'd like to sum them by it.value. So that's going to be the score as an int. Let's say expected score as int. And now we can check that scores is a list of the expected score as int. Or put another way, that scores.first is the expected score as int. But we need to create a score to wrap that. Let's just see whether that's true. Well, it seems to, good. But I should have been taking notice of that yellow, because that's saying this is unused, we need to return it. Meaning that we will in fact return a boolean. Sort of surprised that jqwik didn't warn us about that. But we still appear to be good. And I think it probably is a tighter test to say that the scores is a list of that, because that also checks there's only one of them. Good. I think we can make this a bit tighter by putting the score around there. Just calling that expected score in there. And this would be a nice little utility, so let's pull it out as an extension function. So this is going to be scores given a game. We make this the receiver. We can cut that out of there and put it as a generally applicable nice thing. One more, it would be nice to do the same sort of thing here. If I take this thing as a variable, then I think this would make a good method, which is roll all, and it's used up there as well, which is kind of the point. If we make initial the receiver. So we can take that again out of our test and put it as a top level utility. Good. One thing that's interesting is you might think that it would be nice to take a playable game here, because after all you can't roll any on a non-playable game. If we do though, you see this cast here gets a bit weird. I think to fix it you have to say this as playable game in here. No, that's not allowed. Yeah, as I say, it is a bit weird. So I'm going to punt for now and just say that's game roll all. Go back up and have a look. So now this is very simple. 20 small pinCounts is game, roll all the pinCounts is a completed game. And once again, actually, this is returning unit so that jqwik doesn't have anything to chew on. Let's just go and have a look at what the tests actually say. Boolean property test, roll with small pinCounts ends the game. So it has run that test. I should think that jqwik, if you have a function that returns nothing, considers it a success if it hasn't thrown. I guess it's probably good enough, but maybe we should put in the boolean here. And now we can tidy this one by inlining that. And run. Oh, there we go. As if to prove things, well, I guess we can just make this a single expression with an equals. better. You may have noticed that the tests are now taking quite a time to run. We're up to 1.5 seconds in total, and it just needs to be the truth that property-based testing is going to be a bit slower. It begs the question then whether we should have two separate properties here or not. We could combine these two into roll 20 small pin counts should end the game with the score, the sum of the pins, and then take these two tests and combine them into there. The problem is that if I do this and one of them isn't true, I don't know which one isn't. So for example, if we were to say pin counts drop 1, that would fail. But our error is just that it failed. We don't really know why. Maybe though, with the knowledge that I don't have to return anything here, I can get the best of both worlds. I can say in here, use expect that game roll all pin counts is a completed game, and scores is equal to list of the expected score. Now if I don't do that, and I don't return anything, and let's just put end game back in there. Let's see how that fails. Well, it did fail, and we got our strict diagnostic out to tell us that it wasn't a completed game. That looks like it's the best of both worlds, rather nice. And in fact, it would be even better if I was to say expect that end game and put a block in here so that I can say both those things is a completed game and has scores, and we should be able to see that both of those fail. Although ironically for the case we're taking here, if you look, it's all gutter balls, the score is 0. Anyway, we don't want to test against all but one of the right pin counts. That will do us. That passes, but still lets us know in which way it failed when it does, which is the best of both worlds, and means that we don't need a separate property here for checking that the game is ended. Good. Okay then, thinking it through, I think this property is probably a line with no strikes or spares scores the total of the pin counts, and maybe a completed line. And I think also we might be able to just inline this. So small pin counts is any int from 0 to 4, mapped to a pin count, and then 20 of those. Is that good? It is, so I think that's worth a check-in with start to property test playing games. Splendid. Now a game with no strikes and spares is a pretty boring game. Obviously we want to test strikes and spares, but the problem is, how do we generate a valid game? As soon as somebody scores a strike, we have one fewer rolls in that game. So we're going to need to find a way of generating a list of pin counts to represent a valid and complete game. To demonstrate the problem, let's duplicate this test and try and write there are no errors in a valid game. So this would be valid pin counts, and scoring will be difficult, but we should still be able to roll all the pin counts. So let's get rid of that and that. So we can just say that thing. Now what would valid pin counts look like? Well, we've got small pin counts. Valid pin counts will be anything between 0 and 10. So let's go and try and run that. You see that it's failed. We've got a legal argument exception, which suggests that we failed somewhere in our roll all. Yes, in fact, you see the dotted line there. Let's see what we threw. You see jqwik has been rather helpful here. It said, well, I originally threw this thing that was a 6, a 5, a 2, and so on and so on. And I guess sometimes we're going to roll things like maybe a 9 and a 3, where you can't roll a 3 after a 9, because there aren't enough bits of wood to knock down. jqwik has gone looking for a simpler way of expressing the problem, and here it is. It's all zeros, followed by a 1, followed by a 10. Well, once I've knocked down one pin, I can't knock down 10. So it has found a nice simple sample. But this comes down to the problem that we're generating pairs of pin counts that aren't necessarily valid in a game. Another way of putting this is that a list of independent pin counts doesn't represent a game of bowling. So, what to do? Well, I wonder whether there's mileage in the idea of a turn. So in bowling, players have a turn. If they score a 5 in a turn, then there are 5 more pins that they can knock down in that turn. But if they score a 10 in a turn, then that turn ends. So let's pull on that thread and see where it takes us. What I think we'll try is, instead of going with valid pinCounts, we'll go with ValidTurns. So we'll say this is ValidTurn, and it's a turn. And it turns out that for list, there's also at size. So we can try a size of 10 turns. And instead of a pin count, we want a list of, I think I'm going to call it ValidTurn. And so this is turns, and we want to roll all the turns. Okay, what's a ValidTurn? Let's create ourselves a class for it. And we'll put it in here. And I think a ValidTurn is a data class that has 2 roles. So it has val role 1, which is a pin count, and it may have a role 2, it won't if it's a strike. So the second role is nullable. And to keep us honest, I think we could say that in our init, we check that role 1 plus as pin count role 2. And that may not be here. Let's try that the other way around. Let's say role 2, if it exists, plus as pin count role 1. Now remember that plus as pin count produces a pin count, and a pin count can only be 0 to 10. So this will check that the 2 roles can't add up to more than 10, which is true for a valid turn, except for the final valid turn. Okay, how can we create an arbitrary valid turn? Let's sketch that out given what we have. We'll say fun valid turn, and this wants to be an arbitrary valid turn. Now, jqwik has a combine that allows us to combine other arbitraries. So we can say combine and give it a valid pin count. We don't have one of those yet, but let's just go and pretend it exists. And 2 valid pin count. Come back to the block in a minute. And valid pin count was the thing we took away from here. So it's this thing here. That is valid pin count is 0 to 10 mapped into pin count. Okay. When we combine, we're given 2 arbitrary pin counts. So we'll call that R1 and R2 for role 1 and role 2. And we want to return a valid turn from that. Now we could just pass in R1 and R2, but if we do, we risk falling foul of this init. We could have a role 1 that's 10 and a role 2 that's 10, and that wouldn't be a valid turn. So we'll have to think a bit. And what I think we'll do is we'll say when, if role 1 is 10, then let's just call that a strike, and that will be a valid turn with role 1 and no role 2. If we've got 2 pin counts that add up to more than 10, but the first one isn't a strike, we're in trouble. But we can say R1 plus R2. Now that will give us a score, so I think we'll take the value out of that. And if that's greater than 10, then we need to make it valid, and we can do that by making a valid turn of R1, and R2 is going to have to be a pin count of 10 minus R1 dot value. And I lost my greater than 10 somewhere. That basically means that if we have got a strike but they add up to more than 10, then we'll make them into a spare. And in the other cases, we've got a valid turn of R1 and R2. I'm not entirely sure about that logic, but let's go forwards anyway. Up here we said that we wanted valid turns, so we want something like this, which is a provider. Duplicate that, move it down here, and this is valid turns is going to be valid turn list. Okay, the only thing that's not compiling is game roll all turns. Let's create one of those on game, and it will look a lot, I think, like roll all down here. So let's move it to be with its friend, and this is not pin count, it's turns. And to make this work, I think what we need to do is we need to turn our list of turns into a list of pinCounts. So we can say pinCounts, let's give it its type so that we're made to get it right. This is going to be turns, and we could flat map each turn if it had a to list. What would to list look like? Let's put it into ValidTurn. There it is. It would be an iterable of pinCount. That's good. And we could implement that by saying return list of roll1 and roll2 dot filter out the null ones. And in fact, IntelliJ says, oh, that's clever, isn't it? Look, it could see that roll1 and roll1 weren't null. But if we make that roll1 and roll2 filter not null, and now it tells us that we could do list of not null. Okay. So a ValidTurn can give us a list of pinCounts. We can then use those to build a list of pinCounts from a list of ValidTurns. And then finally here we can return this dot roll all pinCounts. That compiles. Oh, well, it doesn't actually, because our two roll alls have the same signature. Go and find one of them. Here we go, and we know we can solve that sort of problem with @jvm name, and we'll call this roll all ValidTurns. That compiles. Yes, it does. Okay, let's go up and remind ourselves what we were doing. So up here then, we were saying that if we take 10 ValidTurns and roll them all, then we expect to get a completed game. That seems like it's worth a go. Let's run. That has failed. Let's see why. So we'll bring up the results. It failed after one try. And this is what it failed for. It failed for 0, 0, 0, 0, 0, and then a 1 and a 9. If we move down, we can see that actually it failed the first time it tried, and that had a 1 and a 9 there as well. And jqwik has then worked its way back to work out that actually none of these things mattered at all. The only thing that matters is that we rolled a 1 and a 9 in the final frame. And that's a problem because that's not a valid turn in the final frame because we rolled a spare and should have had an extra turn. Aha! So we've got some work to do for the final frame, and I think we'll back into it slowly by saying let's take 9 valid turns and then another valid final turn where we only have the one of it. So we'll call this final turn, and that's not a list, it's just a valid turn. Now, if we do that, then we can roll all turns plus the final turn, which I should have named final turn, and there. And we can give ourselves a provider for this that for now at least doesn't score a strike or a spare in the final frame. So let's give ourselves, we've got valid turns, let's say here, we'll say valid final turn, and that will combine a small pinCount, which again we don't have or got rid of, with another small pinCount. And the small pinCount was this thing. So again, we'll make a method out of that. We'll call that small pinCount. And then valid final turn, we want to mark with @provide to make it used. I think that stands a chance of working, so let's try it. Well, it passed once and twice. Let's run all the tests. That's quite pleasing. It's possible to get a bit blasé about this. I think we'll just check things by saying, again, println endgame to scorecard to see the sort of things that's actually happening. Run that. And if we go to our test results and say there are no errors in a valid game, here we can see lots and lots of games being played, and there are spares, there's a strike, and the only thing that we haven't really done is bowl anything special in the final frame. We also have to check the scores, but we have shown sort of independently that our production code's logic's idea of valid frames matches our valid turns. How then can we do better in the final frame, this last final turn here? Let's see what we're currently using for valid final turn. Here it is. Oh, it's the same code as ValidTurn, but with small pin counts. That makes sure that we don't score a strike or a spare in the final frame. To cover all final turns, though, we will have to allow for the eventuality of a strike or a spare. So I think maybe what we'll do is we'll give ourselves a valid final turn as a type. So this would be valid final turn, and a valid turn always has a roll 1, may have a roll 2 in our final turn, and it may have a roll 3. So that will be an optional pin count. Now then, the constraints on a valid final turn aren't as simple as that on a valid turn, so I think we just get rid of this init for now. But toList should add in the roll 3. And now to supply one of those to our tests, this will be an arbitrary of valid final turn. And we're going to want it to combine 3 valid pin counts. So that's going to be a valid pin count, a valid pin count, and a valid pin count, which means there will be 3 parameters to our lambda. Okay, now you're probably going to see my eyes go up that way as I look for the example I prepared earlier. So, when R1 is 10 and R2 is 10, that is to say we have 2 strikes in a row, then this can be a valid final turn of R1, R2, and whatever R3 is, because all the pins were knocked down the first time and the second time, so they could all be knocked down or whatever the third time. Now, if R1 dot value is 10, we'd say the first one is a strike, and our second roll value plus our third roll's value, so we're going to sum those together, is that greater than or equal to 10? And if it is, then we've got the same situation as we had here, but just with the second 2 rolls. So we need to restrict the number of pins that have fallen down the second time. So I think that is a valid final turn with R1, which is a strike, a pin count of R2, and a pin count of 10 minus R2's value. Sooner or later this will compile, but before it does, we've got to ask the question, the first 2 have covered a first roll strike. What then when R1 dot value plus R2 dot value is greater than or equal to 10? Well, that's a spare in the first 2 rolls, so this will be a valid final turn with R1 as a pin count. The second one will be a pin count of 10 minus R1 dot value, and because that's a spare, the pins will be reset, so we can use roll 3. And then finally we have a valid final turn of R1 and R2, but we can't use R3 because not all the pins were knocked down in the first 2 rolls. R3. Well, that looks like it almost compiles. I think maybe this one here should just have been R2. That means that can go. Oh, right. Let's reformat. And what we're doing here, if you like, is we are finding a way to map random numbers into valid turns in a way that makes sense and hopefully gives a good distribution. We could, for example, have discarded any cases like this one, just sort of tried again. But the nice thing about interpreting anything where these 2 add up to more than 10 as a spare is that we'll get more spares, and more spares are likely to cause us more trouble. They're likely to find edge cases. Okay, I don't think that should compile because I don't think that we should be able to add valid final turns to turns. I think that should be a problem up here. Valid final turn is a valid final turn, but because we're using annotations, the compiler didn't know the type was wrong. So in order to make this work, I think we have to say that this roll all valid turn, well, we can either change it to work with any and then downcast a turn or valid turn, or we can pull a common superclass out of ValidTurn and ValidFinalTurn, or we could make this a list of pinCount, and we could say that ValidTurn and ValidFinalTurn, instead of having two lists, were a list of pinCount. Quite like that final solution, because it means in here we could say that this implements list of pinCount by this expression here. That allows us to get rid of that. And here we are list of pinCount by this expression. So we can get rid of that and that. Maybe just reformat these, make it look pretty. And having delayed a gratification, there is a compiler error somewhere. There we go. So roll all now. That's odd. I did think that the compiler might interpret turns plus final turn as a list of pinCount. Let's pull it out. And all it says is any's. Let's go and check the types again. ValidFinalTurn is a list of pinCount. ValidTurn is a list of pinCount. Well, maybe this plan wasn't so great after all, but let's go back and see what we can do. Maybe if we said here, this is turns as a list of pinCount, that gives the compiler enough of a clue. So maybe we'll just roll that into there, if you'll pardon the pun. Okay, so the big question is now, does that work? Let's try running the tests. Oh, yes, it was staring me in the face. This should be as list of pinCount plus the final turn as list of pinCount. I don't know, I'm beginning to think that was a bad idea. Let's back up. Okay, then what I've done is I've extracted this turn interface that has a roles property. ValidTurn is a turn and its roles are all the non-null roles. ValidFinalTurn is a turn and its roles is all of its non-null roles. And that allows us down here to say that rolling all list of turns is turns flat map the roles as a list. And having run the tests, I fixed this here, where I did in fact have R3, and that led to some invalid final turns. But if we run this now, and look at what we are generating, there are no errors in a valid game. And you can see we started here with a run of gutter balls, then we have spares and strikes and so on. And in the final frame, we have some frames that are just misses, we have some that are just two balls. We have a strike followed by a spare here. I'm not sure that's rendering right, is it? Interesting. I think we found a bug there, but not from a failing test, but only from inspection because we were generating random combinations. Here's a pucker spare, and here's a spare followed by a 9, and here's a spare followed by a strike and so on. So we're definitely generating more interesting final turns than just the raw randoms would suggest. Armed with ValidTurn and ValidFinalTurn, I think we might be able to play a game with more than one player as well. So we could duplicate this and say there are no errors in a valid two-player game. And if we just duplicate this, then we'll put in the commas, this would be turns 1, final turns 1, turns 2, final turns 2. And we can take turns 1 plus final turn 1. And if we bring that out into a variable, then I think we can take that and zip it with the similar thing for the second player. So that's turns 2 plus final turn 2. And then we need to flatten that. That doesn't work because zip gives us some pairs. So I guess what we actually need to do is we need to not flatten turn, but flat map list of it.first to it.second. Evidently something is still wrong. Let's have a look at the type of that. Of course, not list of it first to it.second, but it first and it second. Then the type will be right. Phew. And I'm going to call this interleaved turns. And now we need two players to make this work. We'll just check that it does fail if I try to play a game of one player. And there we go, we completed the game too quickly. We'll find out what with, well, I guess any game at all really. So that's legitimate. But we add in Barney as a player and run. We are good. I'm going to take that out to make everything run a little bit quicker. I think there was one place up here. Where was it? I think we could take small pinCounts and give it a size in here. So this would be at size 10. That would allow us to go and find small pinCounts and allow the caller of it to select the size, not doing it in here. But I note that's 20, not 10, because these are pinCounts, not our frames. Splendid. And there's one more println there. And let's check in with property test for valid turns. Commit. I find it interesting that we've introduced a type here, this turn, in order to facilitate testing. We didn't identify turn as a thing when we were trying to find types in our domain, but it seems quite natural here where we're testing. It makes me wonder whether if we'd introduced turn as part of our production interface, we could have made more states unrepresentable. I know I keep on saying this, but it feels like we're nearly done, but we do still have some testing of the scoring to do. In particular, I think the only scoring we're testing is this here, plus a special case in here of a maximum score is 300. I'm not sure that I've yet got any really good property-based tests for scoring. So next episode I'm going to ask AI assistants for its help, either devising the properties or actually devising some tests. So if you'd like to see AI assistant meets jqwik, then please subscribe to the channel, like this video so other people can find it, and maybe even go out and buy the book that I wrote in that price called Java to Kotlin, a Refactoring Guidebook, details of which are in the show notes below. Thanks for watching.